Good morning, everybody. My name is Atharva Kotwal, and I'm a sailor by profession. Uh, there are times when we have to abandon the ship and we have to board lifeboats. During these situations, we cannot drink water for the first 24 hours. And even after that, we have a limit of zero point 0.6 liters per person. Uh, so, in spite of modern technology developments and innovations, there was no solution to this. So, while brainstorming about this, finding a solution, we uh, we came uh, we came across and we found out that drinking problem is a global issue, and when it comes to disasters, it gets even worse. The people who are stranded, they don't get water to drink, and even if they get, uh, there's always the issue of toxicity, poisoning, other issues. So we at Terranova we have come up with a feasible and an economical solution which will benefit the community and without harming the environment. Uh, well, I'd like to introduce you to you Aquarius. This is a device. This is our first product. It works on a simple principle of condensation. You just take atmospheric air and just condense it to generate pure drinking water. As you can see, it's lightweight. It weighs about a kilogram and a half. Absolutely. If you could hold it by the base, please. Yeah. It weighs about a kilogram and a half. It runs on very low power. You can use your power banks, which is 5 volts, 2 amps, and you can also use AC power, which is your mobile phone chargers, to run it. And we've also introduced and we've also made sure that you can use solar chargers like these. These are foldable, so since it's using so minimal power, you can just open it up and just charge your batteries. With these key features, we want to address three main industries. One is the shipping industry, the merchant shipping industry. The second is the military, where people go on operations and they need water to drink. And the third is disasters. You're looking at tsunamis, hurricanes, floods. People get stranded and don't have water to drink. So that's where our main focus is going to be. About Aquarius, I'd like to tell, we just want to keep it very simple. No buttons. It's just going to be plugged and it's going to start working. That's it. In the future, our goal is to, with the smaller model, we want to make it reach the WHO standard, which says 0.9 liters for 24 hours is the minimum amount which is required for a human being to survive. That's our target for this model. And we would also like to upscale this model to a household where where water is scarce. It's really difficult to walk for miles to get water. Actually, drinking water is, everybody's right, and we at Terranova will ensure everybody reaches. This is my team. Thank you.
So thank you for working on a real problem. Awesome. We exclusively invest in hardware IoT, so I love this. And I'd love to understand, you didn't explain your team. I want to know why you guys are uniquely positioned to do this well. And secondarily, I heard your WHO standard, but where are you today? How much can this output over what duration?
Okay. All of us are mechanical engineers. And after mechanical engineering, I went to merchant shipping, so I'm a sailor. And I personally know this problem because we do drills every time. And I don't know when the weather is going to be rough. And if I get stranded, I know how the situation is going to be. We get only packets of water, which are 0.6 liters. And unless and until you're sick or injured, you cannot drink. It's a rule which is written in our rule book, which is called SOLAS. And about the device, could you just repeat the question?
Yeah, so you said that the WHO standard was 0.9 liters.
0.9 liters,
What can this currently output?
Yeah, the current output, which with the power bank, we are doing 350 milliliters in 24 hours. That's our current output. It's low, but we're currently seeking for seed funding so that we can take it to the 0.9 liter mark and make it an MVP.
What's your thought on pricing and distribution?
Excellent. Currently, our prototype cost, just the manufacturing, since everything is custom made, it's costing about 280 US dollars. And with manufacturing, we've calculated to once it goes into mass production, we can definitely bring the manufacturing cost down to 70 to 80 dollars.
Distribution.
Distribution will be, when it comes to disasters, we're looking at NGOs and national disaster relief funds, which generally help, or the rescue operations generally happen in the country. With regards to military, we can access the governments who require such kind of product. And in shipping industry, we know we have to take approvals for classification societies, which are there present. So that's the way in shipping industry.
Have you already raised capital for your product?
No, we are self-sustaining at the moment.
But how are you going to raise your distribution if you will not get funded? Is there enough funding that you can sort of sustain yourself?
Right now, yes, we can sustain ourselves for a year for now. So we'll be still working to reach the WHO mark, so we can reach a standard to which people will start accessing them much faster.
Can you tell me about the technology? Because I've heard this technology a few times, and I'm sure it's not, it's probably not cheap to do this. And I'd love to understand, why did you pick the technology? Do you have any sort of inside track on a patent to use this technology? Is it something you're just pulling off the shelf?
Yes, we have an Indian patent, and we'll be applying for a US patent soon. About the technology, we're using a semiconductor device, which is basically condensing on our specially designed condenser. Which unfortunately I've sealed it off because I cannot show it to you at the moment. And this condenser, we've calculated how much surface area we need to condense, and according to that, we've done it.
All right, that's all the time we have. Thank you very much, Atharva.